All right. So the question is, we've shown with the scatter plot, that there's there appears to be a linear relationship between the two variables. We've quantified, we calculated correlation coefficient, and we've shown that R was like 0.62. It ain't zero. Let's say that. It ain't zero. So we show evidence of a linear relationship. We were able to create a model to predict episode total based on number of price and games won. So we were able to show all three of these. But what we have not done yet, which is the epitome of all of this, is can we conclude that there is a significant relationship between X and Y? Is there a true? See, we have just shown that a correlation and a scatter plot, a correlation and this regression model, we have shown that there is a linear association between X and Y of the sample data. But what do we do hypothesis tests for? To say, now, have we captured statistically significant evidence to say that there's a positive relationship between price and games won and episode total in general for the entire population? Do you understand? So we got to do a hypothesis test. What is that hypothesis test? It's a t-test. Of course, I got to show you all the 5 parts. So, 5 parts of the hypothesis test. The null hypothesis. There are 2 ways you can set up the null and alternative hypothesis. This is one way. This is called rho. This is a Greek symbol called rho. This is the population correlation coefficient. Rho, R-H-O. Population correlation coefficient. So the null hypothesis for both, regardless if you do left tail, right tail, two tail, the null hypothesis says there ain't no relationship. So right now, under the null hypothesis, before we even do the hypothesis test, even though we've established a model, a potential correlation, we must still assume this until we do the hypothesis test. That there's no relationship between the number of price of games won and the episode total. That's what this null hypothesis is saying. The alternative hypothesis says, yes, there is. Either there's a negative relationship if you do a left tail test, there's a positive relationship if you do a right tail test, or there is some type of a relationship, either positive or negative, if you do the two tail test.
What did you say the little p was again? The population correlation was?
What is p?
The little like p.
Rho?
Yeah, rho.
Rho. So that's like the Greek letter R. That's the Greek letter R. Rho, R-H-O.
But what's it mean?
Well, first of all, it's a Greek symbol. So first word should come out of your mouth is what? Population. And then I told you what its purpose is. It's correlation coefficient. So it's population correlation coefficient. That is sample correlation coefficient because that's a letter, alphabet. Alphabet, first word should come out of your mouth is sample. Sample correlation coefficient. Population correlation coefficient. Now, another way you could have written the known alternative hypothesis, you could have written it in terms of the slope. Okay? The null hypothesis says the true slope is 0. If the true slope is 0, that means you cannot make a linear regression model. Because you kill the model. If the slope is 0, that kills the model. There is no constant plus something x. Because if the slope is 0, it's 0 times the x is 0. It kills the model. Is everybody with me? So basically what this says is there is no true linear relationship. You cannot make a model that shows the relationship between x and y. The alternative hypothesis says, oh, yes, you can. And that slope is either negative, positive, or just not equal to 0. And remember, the two-tail test, you're doing left tail and right tail all in one test. Your question?
What symbol is that?
This one?
Yeah.
Beta. Beta 1. So that's a Greek symbol. That's a Greek symbol. So what's the first word? Population. Population slope. So the true population slope is equal to 0 or it's either less than 0 for the left tail test. Let me put this up on the board. So let me put this back. Let me put this up. We calculated this But that's for the sample. We created a regression model that's based off the sample data. But what we're testing is there a true relationship between X and Y for the population? That's Y equals beta naught plus beta 1X. So if the true population slope is 0, remember under the null hypothesis, this is currently true. Well, if that's 0, look, if that's 0, 0 times X is 0. That dies. Is everybody with me? That means you don't have a linear, all you have to depend on is a constant. Is everybody with me so far? This, if you kill this, you cannot say that there's a relationship between X and Y because you killed it because that's 0. Is everybody with me so far? 0 times that dies. There is no relationship between X and Y left. Is everybody with me? So, no hypothesis says there's no relationship. Alternative hypothesis says, oh, yes, there is. And that relationship is either a negative relationship, positive relationship, or any type, or positive or negative when you do the two-tailed test. Level significance 5%. You know that part. The test statistic. So how did StatCrunch get that t-value that I showed you? It's a function of r squared, and n. Well, if you know r, you can get r squared. It's just r squared. You can get that better. And then sample size, right? So this is the formula that is used to how StatCrunch got the test statistic. So, what was that value? No, that was that. 6277, wasn't it? What was the correlation? It was 0.6277?
0.6277.
0.6277 divided by the square root of 1 minus 0.6277 squared over what was n? N was 188?
Yes.
188 minus 2. So 0.6277 divided by the square root of open parentheses 1 minus 0.6277 squared, close parentheses, divided by 186. That denominator will be 188 minus 2, 186. That dog will hunt. That dog hunt all the time. Look at that, 10.997. Look at the output. Don't look at me like I'm crazy. Look at the output. Look at the output. Okay, I'm off a little bit around the error, but still, now you see where they got it from. Okay? And again, p-value is the same thing as like you did for like the regular t-test. P-value, probability to the left, gives you the p-value. If you did a left-tail test, right-tail test, probability to the right. Two-tail, you have to find both of these probabilities, keep the one that's the smallest and double it to get the p-value. And then of course, if the p is low, the null must go. That's the fifth step. P-value is less than or equal to alpha, you reject the null hypothesis. All right. Trying to see what else I can do. Now, if you didn't have statistical software, you could also determine if you reject the null hypothesis. There's a table A5. I didn't give it to you, but it's the table. It's on Canvas. It's on Canvas. On like course. There's this table. What you do is you find the sample size. And then you find the level of significance, and then it'll tell you what's the critical, the critical R. So you could use this, but the problem is that this table only goes up to a sample size of 100. We had a sample size of 188. So we would have to use this line. What was the level of significance? 5%? So 0.196 would be the, sorry, that shook, so it got me busy. 0.196 would be the critical value. Anyway, point of the matter is, look at the output. The output of the stack price is very helpful. Let's see. What is this? Oh, okay. I gave you all of this, right? Oh, sorry. I gave you all this, right? I didn't take this off of your copy, did I? Is that okay? Okay. So if we were just trying to do a two-tailed test, so here I give you an example of a two-tailed test. We use level significance of 5%. Here's the test statistic. I just showed you that. 10.997. Degrees of freedom is 186. I showed you that the p-value was really small. Rejected, no hypothesis. So what that says is that we have shown that there's statistically significant evidence between those two variables. So now, what we're going to look at, let me see, where are we at? What slide are we on? Oh, this is the last slide. Okay. Can I just show you? You can wrap up, but keep your laptop out if you want, really quick, because I want to show you this. So, going back here, you don't have to do this manually, the predictions manually. So look what I'm about to do. And again, if you want to follow along. If you don't, that's fine. If you go to options and edit and go back into the simple linear regression option, you remember I told you we skipped, where is it? Here it is. We skipped this box here. You see what say predictions here? We can put it 0, 1, 2, 3, 4, 5, 6. And tell StatCrunch to tell us what are the predicted values for us. So what this does is you're telling StatCrunch to say what is the predicted value when no pricing games are 1 game is 1, 2, all the way up to 6.
I didn't do that.
Now, we already did 3. It was 93.510, which is $93,510. If we hit compute, there it is, and scroll down, there it is. See, $93,510. Now, you're like, hold on, but that ain't all we see on this screen. We got all of this over here. That's the purpose of part 2, which is the next PowerPoint. I'm going to interpret these for you. And this is the cool ass shit part. This is the cool part.
Yeah,
Simple?
Simple, yeah.
Okay. So we're going to talk about
And
what
then
these
the
values.
X variable,
Okay.
when
So the next PowerPoint is going to talk about how to predict. What I showed you, we covered
And
that
that's when
today.
he
So we did
changed
a
the
little
right
bit
here.
of the
Okay,
next
so we
PowerPoint.
did
I
this,
gave you an
right?
example. But then this is the part. How do we get these values?
And then
And when did those
prediction
values?
is why he did the
That's what we're gonna do on
1,
next
2, 3, 4, 5,
Okay.
6,
You put 0.
All right, so this is a good place to
Comma?
start.
comma, 1,
Oh,
comma,
y'all ain't going. Y'all ain't going nowhere.
6?
Y'all ain't going
2. Yeah,
nowhere.
I'll do it 6.
Get these damn exams. So y'all know, because y'all ain't fixing. The professor been holding our exams hostage.
Yeah,
Get
that's
these
over
exams.
here, right?
Okay.
Oh, yeah, and that's the
But
one
if
in
you
Denver.
want her wisdom, I still got 5 minutes. Look at y'all. Come get these exams.